Let's solve the equation 1 over x minus 5 plus 4 over x plus 3 equals negative 7 over x squared minus 2x minus 15. First off, this is a rational equation. We have fractions, and what we want to do is clear those fractions. To clear them, we need to find the LCD. Before I start on that, I want to point out one thing. On the right side of the equation, there's a negative in front of this fraction. Now, that means this is a negative fraction, and it's a little hard to see right in front of the fraction bar, so I'm going to move it up into the numerator. Remember, with fractions, you can have the negative on the outside of the fraction, or you can have it on the numerator of the fraction, or you can have it in the denominator of the fraction. And generally, for working with equations and adding and subtracting, it's usually a better idea to have it in the numerator or out front. And because out front, it's actually kind of getting confused with the fraction bar, I'm going to move it into the numerator. All right, so let's look at these denominators and find the LCD. My first fraction has the denominator of x minus 5. That's not going to factor, so I'm going to leave it as is. My second fraction has a denominator of x plus 3, which again doesn't factor, so I'll leave it as is. And then my third fraction, again moving the negative into the numerator, so I've got a negative 7. When I factor x squared minus 2x minus 15, negative 15 will factor into negative 5 and positive 3, which does make that negative 2x in the middle, so it will factor to x minus 5 times x plus 3. And that's very convenient because those two factors are exactly the factors we had in the first two fractions. And that kind of shows us that our LCD is going to be x minus 5 times x plus 3. All right, because x minus 5 in the LCD is the same denominator as we have in the beginning. X plus 3 is the same one in the middle fraction. And then the whole thing gives us the denominator in the last fraction. So the LCD incorporates all three of the denominators. What we're going to do to clear fractions is multiply every single term by that LCD. So we're going to multiply the first fraction by the LCD over 1. And again, we're multiplying by over 1 so that we can then, when we multiply it by the first fraction, we're able to cancel this x minus 5 so that the denominator of the first fraction goes away. And we're allowed to do this as long as we do it to every term in the in the equation, because remember, as long as you do the same thing to everything in the equation, then you still have a true equation. So I'm going to take plus the LCD over 1 times the second fraction, and then equals the LCD over 1 times the third fraction, which is the one on the right side. And then have some fun canceling, because I can cancel the x plus 3 in the second fraction. I can cancel in the entire denominator on the fraction in the right side. So what's left is going to be the 1 times x plus 3, 4 times x minus 5, and then just the negative 7. So let's write that out. So 1 times x plus 3, sometimes it's very helpful to write it out before you try to multiply it out, and then 4 times x minus 5. And then on the right-hand side, just simply that negative 7. Perform your distribution. 1 times anything is that thing. And then 4 times x is 4x. 4 times negative 5 is negative 20, equals negative 7. And then this is a linear equation because we don't have x raised to a second power. So we can go ahead and just collect like terms and then isolate x. So x plus 4x is 5x. 3 minus 20 is negative 17. And then we have a negative 7 on the right. We want to isolate x, so first move the negative 17 over by adding it to both sides. So when I add 17 to negative 7, I get 10. And then x is multiplying by 5, so divide out the 5. So x is equal to 10 over 5, which is 2. So there is our possible solution. It's possible right now because we should check it. So to check this, you could check it on Scratch. You could check it by throwing it into a calculator. If this isn't a test, you could check it by looking at the graph of both sides of the equation in Desmos and see where they cross. But since I have just a blank paper right here, I'm going to show the check out by hand. It's good practice with fractions. All right, so 1 over, to check this, I need to go back to the original equation. So I'm going to plug the 2 in for x. 1 over 2 minus 5 plus 4 over x plus, whoops, need to put the 2 in for x. Let's try that again. 4 over 2 plus 3. Is that equal to negative 7 over 2 squared minus 2 times 2 minus 15? Once again, you could use your calculator to simplify these. I'm going to practice the fractions myself. I've put a line here where the equals is because really when we check, what we want to see is that we have the same thing on both sides of the equation. So if I simplify this, on the left, I get 1 over negative 3 plus 4 over 5. And then I want a common denominator. Remember how I said it's easier if the negative is on the other side of the fraction? I'm going to make this a negative 1, and then the 3 and the 5 would give me a common denominator of 15. So I'm going to multiply that first fraction by 5. So actually 1 times 5 is 5 right here, and then I would have this over 15. And then continuing on, we would have plus, I would need to multiply the 5, the 4/5, by 3 over 3, so that I create a common denominator of 15. So that would be 12 over 15. And then adding these two numerators together, negative 5 plus 12 is 7, and that's over 15. So on the left-hand side, I get the value 7 over 15. Let's take a look at the right. Negative 7 over 4 minus 15 when I calculate 2 squared and 2 times 2. Continuing, negative 7 over, well, 4 minus 4 is 0, and then a minus 15. And notice the negative outside the fraction and the negative inside are going to cancel each other out, so I get 7 over 15. So I get exactly the same thing, so that checks my solution. So the only thing left to do is to actually say this is a solution. And generally, we'll talk about the solution set. So we would say the solution set to this equation is, and then we use set notation, which we brace to close your brace. So we use braces to represent the set. So the solution set is 2. Okay. Our next equation is x times x minus 3 equals 5x plus 10. This initially doesn't look like a quadratic, but as soon as you distribute x through the terms in the parentheses, you will see that x squared pop up. So x times x is x squared minus x times 3 is 3x. And on the right side, we still have 5x plus 10. Now, that x squared tells us it's a quadratic. It is positive where it currently is, so let's leave the x squared where it is and move the other terms that are on the right side to the left to create a 0 on one side. Because when we solve a quadratic, we want 0 on one side. So we're going to have x squared, and then minus 3x minus the 5x that moves over is minus 8x. And then that 10, when it moves over, is a minus 10. So we actually have a trinomial equal to 0. Now, we could try to factor this trinomial, and I recommend spending 20 seconds, 30 seconds trying to factor it. Once you realize it doesn't, or if you have trouble seeing the factorization, go to the quadratic formula. In this case, this won't factor, so let's solve for x by using the quadratic formula, which, as you remember, is a fraction. So we're going to start with negative b, and b is negative 8 in this case. Sorry, negative b, and b is negative, I should say, plus or minus the square root of b, which is negative 8, squared, minus 4a, which is 1, and c, which is negative 10. Now notice my bar for my root doesn't go far enough, so extend it. Neither does my fraction bar, so I'm going to extend that. And in the denominator, we're going to have 2 times a is 1. So now we have everything plugged in. We just need to simplify. So remember, we're solving for x, so we continue to say x equals negative 8 is 8 plus or minus. We square the negative, including the 8, so that would be 64. When we have negative 4 times 1 times negative 10, we get plus 40. And in the denominator, we have 2. Continuing to simplify, we have 8 plus or minus the square root of 104 over 2 in the denominator. All right, so if this were an application, I'd just go ahead and use the calculator to approximate these values right away. Since this is an abstract problem, we'll go ahead and practice simplifying square roots. So this square root, we can simplify it if it has a perfect square in it, and it does. 4 will divide evenly into 104, specifically 4 times 26. Remember, this is still over 2. And the advantage of being able to have a perfect square factor is that the square root of a perfect square actually is a whole number. So that 4, square root of 4 rather, becomes a 2 on the outside of the square root. And technically, remember, these are multiplied. So this is 2 times the square root of 26. And this is still over 2. At this point, when you're simplifying the fraction from a quadratic formula, you can simplify if you have a common factor between the term in the denominator and the two terms in the numerator, specifically the 8, and it has to be the number that multiplies, it is on the outside of the root, okay, that multiplies the root. So notice 8, 2, and 2, those all are even, so have a 2 in common. So if I take a 2 out of the denominator, I get a 1. 2 out of 8, I get a 4. 2 out of 2, I get a 1. So what I'm left with is x equals 4 plus or minus. 1 times anything is just that thing, so I get the square root of 26. And then the 1 in the denominator doesn't need to be written. Anything over 1 is just that number. So these are our two solutions. And now we need to check them. To check, it's much easier to check if you're working with decimal values compared to the square root. So let's use our calculator to check our answers with the approximated values. So let's go ahead and find them. Using your calculator, you would go 4 plus the square root of 26 to get one of them. And when we do that calculation, we get 9.10. And then if we subtract the square root of 26, so 4 minus the square root of 26, we get negative 1.10. So we get those two solutions. We should check them both. When we check, we want to go back to the original equation. So we're going to plug that in. So 9.10 times 9.10 minus 3, is that equal to 5 times 9.10 plus 10? Calculate the left and the right side. When we calculate the left side, we get 55.51. We calculate the right side, we get 55.5. Now that's not exactly the same, and usually we want it to be the same when we're solving an equation like this, and checking a solution, I should say, because we want the equation to be true. But these are really close, and in fact, if you look at where they differ, it's actually at the second decimal point, and we rounded at the second decimal point. So this is most likely related to round-off error, which is why these aren't exactly the same. So that's good enough for our check. Then we should check the other number, negative 1.10. Both of these numbers should work. You should never have any extraneous solutions in quadratic equations. So plugging that negative 1.10 in, we would have negative 1.10 times negative 1.10 minus 3 on the left, and on the right, 5 times negative 1.10 plus 10. And calculating here the left and the right side, on the left side I get 4.51, and on the right I get 4.5. Once again, approximately the same thing. They're only off at the second decimal point, so that checks as well. So what we have here are two solutions that check, and those would be the solutions to our equation. So the solution set is, and use a brace, and I'm going to write them out separately, starting with 4 minus the square root of 26, because it is tradition to write the smallest number first, and then 4 plus the square root of 26. And there's our solution set.